Welcome to IMCEI. Today's topic is remainder theorem. To find the remainder of any algebraic expression, first we need to equate the denominator with 0. Here x minus 1 equal to 0, so x equals to 1. Now we need to put the value of 1 here at the numerator. So the net value is coming 6. So the remainder is 6. Now we need to remember, in case of algebraic division, negative remainder is possible. The next question is to find the remainder of 8 to the power 100 by 7. Now first, as the numerator is bigger than the denominator, first I am splitting 8 as 7 plus 1. Now 7 is divisible by 7, so 1 is left. So 1 to the power 100 by 7. Now 1 to the power 100 is 1. Now if I divide 1 by 7, the remainder will remain 1. Now the next question is to find the remainder of 2 to the power 100 by 9. Now here the numerator is already less than the denominator. So we need to find the value of n where 2 to the power n plus 1, 2 to the power n minus 1 is divisible by 9. If I put n equals to 1, I'll get 3 and 2 to the power n minus 1 will be 1. Both of the number are not divisible by 9. Then n equals to 2, 2 to the power n plus 1 will be 5 and 2 to the power n minus 1 will be 3. Again both the number are not divisible by 9. Then n equals to 3, 2 to the power n plus 1 is 9. Now here 9 is divisible by 9. So now the quotient is 3. Now we have to divide the power 100 by 3 and find the quotient, which is coming 33, and the remainder is 1. So 33 will be the power here, and 2 to the power 1 we have to write separately. Now 8 I can write in the form of 9 minus 1. Where 9 is divisible by 9, then minus 1 to the power 33 is left. Now minus 1 to the power odd number will give us minus 1 only. So minus 1 into 2 will give us minus 2. So if I divide minus 2 by 9, the remainder will become minus 2. But negative remainder is not possible. For that reason, we need to add the divisor with minus 2. So the net remainder is 7. Now the next question is to find the remainder of 7 to the power 100 by 35. As we can see, both the numerator and denominator is divisible by 7. So we are extracting as many 7 as possible. Now here we are dividing 7 to the power 100 by 7. We are getting 7 to the power 99, and 35 by 7 we are getting 5. Now there is no more common factor. Now the numerator is more than the denominator. So we are splitting it 5 plus 2. 5 is divisible by 5, so 2 is left, so 2 to the power 99 by 5. Again we need to find the value of n. For that 2 to the power n plus 1 and 2 to the power n minus 1 will be divisible by 5. If I put n equals to 1, we'll get 3 and 2 to the power n minus 1 will be 1. 3 and 1 both are not divisible by 5. If I put n equals to 2, we'll get 2 square plus 1, which is 5, that is divisible by 5. So the power is 2. Now we need to divide the quotient, that is we need to divide the power 99 by 2 and get the quotient, which is 24. And the remainder is coming 1. We have to write down the remainder separately. Now 2 square means 1 less than 5. So we can express in the form of 5 minus 1. Now here is 5 is divisible by 5. So minus 1 is left. Minus 1 to the power even number will give us 1 only. So 1 into 2 is 2. So finally the remainder is 2. But as we have taken 7 as a factor, so the net remainder will be 7 into 2, which is 14. Now the next question is to find the remainder of this expression. As we are dividing all the terms by 11, so first term 121, I am dividing it by 11, getting the remainder 0. Then I am dividing 123 by 11, getting the remainder 2. Then 125 by 11, getting the remainder 4. And 126 by 11, getting the remainder 5. As I am getting the remainder here 0, so I am ignoring this remainder. Now for the net value, the net remainder is coming 40. 40 is again greater than 11. So we need to divide 40 by 11 once more and find out the final remainder, which is coming 7.